today we'll speak about Godot Kotlin, which is JVM bindings to the Godot engine that enables to write some your game logics, your game scripts using Kotlin or Java. So let's start with the basics. Tristan, go ahead.
Yeah. So if we can switch my screen. Yeah. So to use Kotlin with Godot, you need to use a custom build of Godot. It's similar to how you have to use a different build for using C#. So to do that, you need to visit our GitHub page, which is simply called Godot Kotlin JVM, and go to the release page to find the latest version. So here, that's the version of our latest release. And you can find the version of Godot it's built against. And you can simply download the editor that matches your system. And once this is done, you're going to find in it just the Godot editor plus a jar. So if you want to run Kotlin alongside Godot, you need the jar always next to your editor, otherwise it won't run. And because we're talking about the JVM, you also need Java installed on your computer, at least version 11, and the Java home environment variable set on your computer as well. So let's start by trying to create a Godot project using Kotlin. So for that, you start the editor and you create a new project, just like you do in a regular Godot project as well. So we start the engine here. And as you can see, we have a new project here, which is a perfectly normal Godot project. You just have project Godot and all the minimal files. But we need to create now a Kotlin project. So we're going to use Gradle. And nicely enough, we got a utility to do that. You go to Project, Tool, Kotlin JVM, and you generate a project. Generate all files. And now you got on top of your Godot project, a Gradle project. It's extremely basic. Like if you open it, it's simply going to use our own custom Gradle plugin, which is going to download all the dependencies for you, as well as a compiler plugin to create the glue code necessary to communicate with Godot. I won't go into details about what those parameters are. Just know that by default you can run on desktop, but if you want to run on Android or iOS, you need some extra configuration, and you can find that in our documentation. So as part of the generation, we had a basic Kotlin script created. You can open that in the Godot editor, but I don't recommend this way because we don't have auto-completion, we don't have static analysis or anything. So just forget about doing that in Godot, and instead we're going to use what most people would use for a Kotlin project, which is IntelliJ. So just open the created project. We wait for the Gradle project to build. So just a second. And we can then open our script. So how to create a script using Kotlin? It's extremely basic. So you create a regular Kotlin class and you just inherit a Godot type. So if you want to know the Godot type to use, you can just go to the official documentation of Godot, because we are trying to get to be one-to-one with the official documentation. So any type or any method and properties are going to be the same. Only difference is the spelling will be camel case instead of snake case. And we have a few differences, and if you want to find them, you can just visit our own documentation to see the Kotlin-specific syntax. So you also have the whole documentation available directly in Kotlin as well. So if you have doubts, you don't need to visit it. You can just check here. So now, once you created your script, your class, you have to add a few notations. Register class for the class, register properties for the property, and register function for the function. Here, it's a simple hello world script. So When the object is going to enter your scene, it's simply going to print hello Godot to the screen. So let's try to do that. So we create a node, and to add the script, you just drag and drop it on it. And if you try to start the scene, you see that nothing happens. Why? Because you didn't build the Kotlin project. So for that, you just simply press build here, or you can use a regular Gradle action. It's going to build. And as you can see, there was a warning here before, it disappeared. So if you forgot to build your project, you are going to get a warning to tell you, okay, you forgot. If you try to run the scene now, okay, we have a hello one put in the console. Nice. And here in this script, we are missing one key function of Godot, which are signals. Signals are the way you can remove coupling in your code. So basically, it's a publish subscribe system. So let's try to use a signal here. So for that, you just create val max signal by signal one string. So here we are going to use a signal that emit a string, and you have to name it as well. So there is a key difference here compared to regular Godot when you use JavaScript. In JavaScript, signals are untyped and they use a vararg. It means that when you emit a signal, they can emit any number, any kind of argument. In Kotlin, we like to be type safe, so you have to type your signals using generics. And if you want to use that, you need to connect this signal to a callable, a function. So we can try to do this. Fun, print a text. We are going to take a string as parameter, and we are simply going to move the text here, this code here, and instead we're going to connect the signal. So you just simply do my signal, connect this, and you can simply pass a method reference to your function, and it's going to work. Here it's type safe, so max signal emit a string. You can hit it to a function that also take a string, and if you remove the parameter, you get an error because it's no longer matching the types. Also, again, don't forget the annotations, register function, and for the signal, you simply use register signals. There we go. So if you go back to Godot, wait a second, we just need to emit this string, and then you need to also emit the signal itself. So emit, and let's say I want to simply emit the property here. So we go back to Godot. As you can see, we have the warning back because we changed the source code, and it means we need to rebuild again. Okay, and it's gone. So if we try, for example, to change the string, hello game dev day, and we simply save and start the scene, we have our hello world using the signals with Godot. So yeah, that's it for the basics. And now I'm going to let Piatoma talk for more interesting things.
So in this part, I'll show you how you can use some awesome Kotlin features to create your game using Godot engine. And for this purpose, I'll use the JDQuest 3D demo that was originally implemented in JavaScript, and we just readapted it to Kotlin to show the language features. So as you can see in this game, we have some water, and if the player goes into this water, its position should be reset. So let's take a look at how it's done in code. So here we have a really simple class which is called DeskPlane that represents the water. It extends the Area 3D class from the Godot engine, and this class has an already implemented signal, which is called body entered. This signal takes a node 3D as a parameter, and it's basically the node that enters the area. So Tristan already shows you how you can create some signal, connect the signal to a method, and emit a signal. But here I'd like to show you one feature we implemented in Godot Kotlin. As Kotlin is object-oriented but also functional programming language, you can directly connect a signal to a lambda. So this means that each time the body entered signal is emitted, this code block will be run. So in here, we just check if the parameter that we have is a player, and if it's the case, we just reset its position. So if I go in the water in the game, my position is reset. Then you see we have some boxes in the game, and I'd like to show you the code of the game script of those boxes to show you some Kotlin features. So let's take a look. So here is the box class that inherits rigid body 3D, which is a physics class from Godot engine, but also implements a damageable interface. This interface just defines a damage method, and interfaces can be a good alternative in some cases to Godot node groups. Let's take as an example the bullet script. So the player can fire a bullet in the game, and when it collides with the node, here we just check if the node is damageable. Then, thanks to Kotlin Smartcast, we can directly call the damage method on the damageable. We also have some helpers methods to directly cast some nodes to the desired type. So let's take a look in the Godot editor to the box scene. So in here, you can see we have a node called destroyed sound that is of type audio stream player 3D. In the code of the box, we just fetch this node from the scene tree, and thanks to this method, it will be directly casted to audio stream player 3D. We have some kinds of method on the packed scene. You can directly instantiate a packed scene to the desired type. Here we have destroyed box, which is a type we implemented in Kotlin. Then we saw that the bullet script is calling a damage method from the interface, and I'd like to show you the implementation of the damageable interface in this box script, because in here we use one of the coolest feature Kotlin has, which is coroutines. Coroutines is a way to make some code to run concurrently with the rest of your code. It's a way to switch between threads without taking care of those threads. So in this coroutine, what we do, we just await load a packed scene. So this means that it will load in background. The coroutine will pause until the packed scene is loaded. When it's loaded and instantiated, we just await main thread. So here it's another method we implemented. The coroutine will just pause for this code block to be executed on the main thread. So here we just add it as child. Then we just do pretty much the same with the coins that should pop when the box is destroyed. We just load the resource, and then we just instantiate it and add it to the scene. The last part is disabling the collision shape and playing the destroy sound. The destroy sound, so from audio stream player 3D, has a signal which is finished, and we implemented a way to wait for signals in a coroutine. So here the coroutine will pause until the finished signal of the destroy sound is emitted. And after it's emitted, we just free the original box. So if I go in the game and fire at some boxes, you can see that the box is destroyed and we have some coins popping. One other feature, the last feature I'd like to talk to you about is abstract classes. So here we just defined an enemy abstract classes that also inherits rigid bodies 3D and damageable. This abstract class just define a des method in here that does pretty much the same as what we saw in the box game script, except we don't load a destroyed box but a smoke. And there's also another change you might notice, that we are not using a constant to make the coin spawn. So in here, we just use an abstract property that is implemented in both of the inheritors. So if you look to the B-bot, which is the flying enemy in the game, here we have a default value of 7. And for the beetle here, we have a default value of 5. You can still override those properties in the Godot editor, like any regular exported property to the Godot engine. So if I go in the game and find some enemies to fire at, and hoping I'm not too bad to this game, I'm bad. So here I got 5 counts that spawns, and here I got 7. And that's it for the feature I wanted to show you. But I still have one more thing. During this project, we managed to make some JVM code to run on the iOS platform. And I'd like to make a big thanks to the multi-host engine maintainers that helped us by speaking with us about how to get this running on iOS using GraalVM native image. And so you can see here on my iPhone the game running using Kotlin game scripts. So now I'll pass the mic to Cedric. The floor is yours.
Thank you very much. We now just saw how to set up a basic Godot Kotlin JVM project, and we saw how to use some of the awesome Kotlin features and helpers that we ship with the project. But what about third-party libraries? I mean, one of the key advantages of the JVM ecosystem is its vast amount of battle-tested libraries and frameworks. So we might want to use them. And to quote Tristan here, Godot doesn't have a dependency manager, but the JVM does. So we want to make use of that. So to showcase that and how you can use regular JVM dependencies in your Godot games, I threw together a quick demo for you. If we run that game, it doesn't do much currently, because what I want to do now is basically display just the time. So I know I won't talk too long in this talk, and we finish on time. So how do we do that? Because I'm lazy and I don't want to implement the timer myself, I want to use a library for that. Luckily, JetBrains has got my back, and they provided a nice little library called Kotlin X State Time. And I'm going to just use that. We add that as a regular Gradle dependency, like we would do for any other JVM-based project. And with that dependency added to our project, we should now be able to use that. Because I want to display the time in that label, I maybe want to format it, because like for most datetime libraries, I get back an instant and not a nicely formatted string. So let's quickly write a formatter for that. And down here, you see the label that we previously saw, which we want to fill now with the current time. We do that in the process function, and the process function in Godot runs once every frame. So let's quickly populate that. We get the current system time from the library. We convert that to my current time zone, where I'm living, because, well, the timer is for me. And we format the instant that we get back. And just with that, after we recompile and run the game again, we should see the current time. Lovely. While this is quite simple, this allows us many things to do, because I basically just imported the datetime library, but this could be anything like JSON or Jackson for JSON serialization or XML serialization, or basically almost any other JVM library that is out there. Well, this is nice. We want to develop games, and we want to develop a lot of games sometimes, and we sometimes write code that we want to use over and over in each of our individual projects. So what about our own libraries? To showcase how our project can help with you, if you are a library developer, I quickly threw together a chat SDK. This chat SDK is a JVM library or JVM dependency, which consists of a backend, which runs on a server, and a client implemented solely on the JVM as a terminal client. If we quickly see how this looks like, we can quickly run our JVM client, and this just prints the chat messages that are running on our server. And we see our users happily chatting along. Let's keep that running for now. So let's see, I want to integrate that chat SDK that I wrote for different JVMs. For example, for the server, I maybe have an Android client somewhere, or just as that as a command line client. I want to use that in my Godot games. So I can quickly just create a Godot SDK and write Godot specific code, where I can register classes to Godot, export some properties, and set up the whole SDK in my project. So this is nice, but how can I use that in my project? Well, it's basically the same like any other dependency. I just add that to my project dependency list down there, and I resync the project, and I built the project. And that was basically it. After my project is built, Godot should now be aware of these classes that I just put there as a library. And after it has finished compiling for me, we can just show the Godot editor. In there, we see the sample scene that I showed previously with the time label that we saw there. I prepared a little chat window alongside it, so we can see the chat messages in there. This is implemented as another scene, and on top of that, we now want to add the script of our library. You saw previously that you can just drag and drop your source code onto a node, but we only see the demo code that we have had earlier in our project in there. So what we're going to do now, because our libraries are distributed as a jar file, and there we don't have access anymore to the source code we had. So we can't just drag and drop the source code file onto the node and expect it to work. Well, for that, we create so-called registration files for you. For each class that you write, like the demo, for example, back there, we create a secondary file called demo.gdj. GDJ stands for Go.jvm. In this registration file, this is just a metadata file, so Godot knows that this class exists. Instead of dragging and dropping source code files directly onto nodes, we can also drag and drop these registration files. These have some nifty features which are documented in our documentation page. And as you see now, we have a secondary folder in there called dependencies. And in here, we now see our chat SDK together with the two classes that our SDK provides for us. So let's drag and drop that one onto our node. And on the right side, we now see the properties which are provided by the library for us. So let's quickly fill that up. We want to have a packed scene which gets instantiated for each chat message that we want to receive. We want to assign the chat list node to which chat messages are drawn to. We will provide the scroll container, the message input label so we can send chat messages, and the send button. After we set that up, we need to also set up the individual chat list items. Here, it's basically the same deal. We drag and drop the registration file onto it and just populate the individual exported properties from the library. And with that all set up, we can basically just run the game again, and we should have chat messages pop up again. And we just see the chat messages that we have. Just like that, we have implemented a little chat client. And as you can see, they are in sync. And we can also just send a test message, which arrives also on the JVM client down there. So just like that, I implemented a small library that I wrote myself, which runs on the JVM, which I already had, because I had a chat application already maybe, which was running on a server. This this Jet SDK can share JVM code. We have a shared module, which can be shared between the backend, between the regular JVM client, and now also between our Godot projects. And just like that, I quickly implemented the chat functionality within my game without writing too much code for that. So what have we just saw now in my part? We have seen how to easily add third-party dependencies from the JVM ecosystem. And we saw how you can create your own libraries with your own functionalities, which you can ship together with your individual game projects. You don't have to re-implement everything each time. We also saw that we not only allow to drag and drop scripts onto nodes, but also so-called registration files. I really encourage you to read the documentation on our project site regarding them, because these are really nice features that we offer in our project and can really help you write nice Kotlin code. And yeah, that's basically it from my side. I want to thank you very much for your attention and have fun writing games with Godot.